Hello, welcome to another lesson on All About AI. In today's lesson, we are going to dive inside how data is being collected for machine learning. In machine learning or AI project, everything starts with business requirement. Once business requirement is defined, first thing is to collect data. Most of the time, it's one of the very challenging tasks to collect data. It's not so simple as it looks like. Data collection is equally hard as oil exploration. Only difference with oil exploration and data is there is abundance of data in many cases, but most of the times it takes a lot of planning, thinking, and innovation to capture data for specific requirement or use cases. And do remember, it's not as simple as it looks like in Kaggle competition. In Kaggle competition, most of the times problem, matrices, and as well as data is given. I'm not denying that competition is not hard. Definitely, there is a cutthroat competition, but the most of the times the problems those are people are going to encounter in Kaggle competition, they already have the data set. This is not similar as real life project. In real life, first of all, it will be extremely difficult to find right kind of data in many of the projects. We'll see there are many challenges associated with data collection. But before that, let's dive into what are the key components of data collection or the ways usually data collections are being done. Web scraping, crowdsourcing, sensor data, public datasets, synthetic data, APIs, user interactions, surveys and questionnaires, social media mining, experimental methods, environmental interaction, transfer learning. These are few of the many ways of collecting data. Now we'll go one by one and briefly talk about what it is. Web scraping is the automated collection of data from websites using bots and crawler. And most of the chat bots are heavily using web scraping to collect data. Crowdsourcing. All those big tech companies which are building massive scale AI tools like ChatGPT or DALI or even like say Google Photos, all these are gathering data through contributions from many individuals, often via smart tools and platforms like Amazon Mechanical Turk. Another source of data is through sensors. Sensors are being used now to collect huge amount of data. Maybe some of them are like IoT devices, smartphones, wearables. There are many sensors used everywhere to capture data. Public datasets. There are extensive collections of data made available by government regulators and other public organizations or even many private institutes. Those are rich source of data. Synthetic data. Using algorithms to generate artificial data that resemble like real data. In many domains, synthetic data or generated data plays a vital role. API. Accessing data from various online services and platforms to their application programming interface. Like Amazon or any kind of e-commerce site, all of them are collecting a lot of data and mostly all these are through APIs. User interactions. Collecting data from how users interact with existing AI systems or applications. Like Facebook, Instagram, which one someone is clicking, where they're spending more time, YouTube video, where they're dropping. So all these interactions are captured to gather data. Surveys and questionnaire, these are maybe one of the oldest way of gathering data, which is heavily used in many domains. Social media mining, extracting data from social media platforms. Facebook, Instagram, YouTube, Twitter, X, all of them have tons of data and they are capturing data and mining those data for various AI and machine learning project within their organization. Experimental methods. There are different ways to collect data, setting up experiments to see human behavior or customer behavior, like A/B testing or conducting scientific experiment to gather precise data under certain controlled conditions. Environment interaction. In many domains like reinforcement learning, the AI agent collects data by interacting with environment and collecting valuable information about environment, observing results, taking different kind of actions, and what is the corresponding output. All these are captured as a rich source of data for simulation as well as later fine-tuning the model. Transfer learning. Leveraging a pre-trained AI model for a new task. Essentially, reusing the data from one area to another area. This is heavily used in those places where data is not adequate or not abundance of data available for a particular area, but the knowledge can be transferred from very similar thing from one to another. Now, we'll take two examples. First, let me go through about Alexa. So what are the methods being used to collect and fine-tune the model in case of Alexa? Alexa is a voice assistant. It uses voice recordings, samples of human speech in various accent and languages, text transcriptions, written versions of spoken commands and queries, user queries and comments, common requests made to Alexa devices. So these are more like a continuous learning. As people interact with Alexa, it learns from those instruction and information. Interaction logs, records of how user interact with Alexa and its responses. Third-party integration, data from partner service and apps. Public datasets. There are many open source speech and language datasets which were used for initial training or even continuous retraining. Synthetic data generation, computer generated voice samples and queries. Crowdsourcing. Again, crowdsourcing plays a vital role in success of all these AI tools. Data collection in crowdsourcing, data is collected through platforms like Amazon, Mechanical Turk, and many similar platforms. Supervised learning datasets, manually level data for training specific features. Knowledge bases, structured information from various sources for answering questions. Web crawling, information gathered from public websites to expand the knowledge. User feedback and corrections, improvements based on user input and error reports. So you can see that's collected data from various sources, various ways, and it also requires a lot of fine-tuning over the years once it starts gathering input from user interactions. Another very well-known and common usage of AI tool is Google Photos. Google Photos were trained using huge amount of internal datasets. As you know, Google has stored tons of data for a very long time. So they have a rich set of internal datasets. There are public datasets available in computer vision research. Those were also used for training. Metadata extraction. Metadata such as timestamps, location, and device information extracted from photos to provide context. User uploads. Photos uploaded by user to Google Photos with user consent. So if you upload a photo, that's in a way helping Google Photos to fine-tune or improve its model. So every time you upload one photo, it's becoming one more data collection. Synthetic data. Computer generated images to augment training sets for rare objects or scenarios. A manual leveling. Human annotated images to create ground truth datasets for supervised learning. User feedback crowdsourcing. User label and tag people, places, objects in their photos, which help train model for better recognition accuracy. Google Street View, image collected for street level recognition and geolocation features. So you can see how Google has integrated their rich set of data collection from different areas to train their specific products. Data collected from one area can be used in another area. And that's how companies are smartly using their data. And there's a whole team working day and night to fine tune data collection and how they can automate this process, how crowdsourcing can be used to improve their model performance. There are also licensed content being used to train the model, like stock photos or other licensed images database for diverse training datasets. So, as you can see from these two examples, there are many ways to collect data. But there are a lot of other challenges while collecting data. Type of data: text, image, audio, video. There are many types of data. Volume: large datasets are often required for complex AI models. So, volume plays a major role. Cost and time: collection cost, labor cost, all are involved. Even the collecting data can be time consuming. Privacy and ethical concerns: user consent is required, data anonymization is required, bias, fairness, transparency, all these things comes into picture while collecting the data. Data leveling: the quality and accuracy of data cleaning, noise and outliers, data security, like ensuring there is no data breaches, data are integrity, so that there is no tempered or corrupted data, protecting data from unauthorized usage. So data security is immense importance while collecting the data. Data availability: in certain cases there are limited amount of data. In certain domains, particularly in rare cases like in medical cases, say certain types of cancer may be very rare, but that data is critical for training the model. Proprietary data: access to certain data sets may be restricted due to proprietary or competitive reasons. Data integration: there are many heterogeneous sources of data coming from many places, maybe many geography. So there is a plan required to be how to format, structure, integrate, and store them. There are many data silos. Breaking down organizational silos to access comprehensive data, it's a phenomenal challenge for any large organization. Scalability: handling and processing large volumes of data efficiently, that itself is a phenomenal task. And those Google scale organization, they have huge data centers to manage scalability. There is another challenge is in terms of scalability is real-time data. Collecting and processing data in real time for applications like autonomous driving or financial trading, that requires sophisticated infrastructure. Regulatory compliance: there are many data protection laws. Adhering to laws like GDPR or CCPA in California, which govern how data can be collected and used, how long it can be retained, how the data need to be disposed. So there are many challenges associated with regulatory compliance. There are industry-specific regulations like HIPAA, HIPAA for healthcare data. As we mentioned about technical infrastructure, storage, processing power, data transfer, all these require a lot of investment as well as technical capabilities. Data relevance: many data at the time of collection, maybe it's serve the purpose, but over the period of time, the context of the data change, and it's important to keep data up to date. As world is moving constantly, it's always a challenge for all these AI model to remain up to date with relevant data, because your prediction or any AI outcome depends on relevancy and how recent the data is. So you can see there are many aspects of data collection, and many of them are extremely challenging. And everything need to be thought through at the time of data collection stage itself. Next, I'll quickly highlight few research papers about data collection. This is not so important for AI enthusiasts. You may want to skip this, but for advanced level and expert level, AI practitioner and AI wizard level, it's extremely important that you do refer to different research paper to understand how the specific areas research is moving. So you may want to refer a paper titled A Survey on Data Collection for Machine Learning. Lead writer is Yuzi Ro. So this talks a lot about data collection processes. Data collection is split into data acquisition, data labeling, existing data. Then there are also different variations in acquisition like discovery, augmentation, generation. You can go through the paper, and also there is a very interesting flowchart. If you refer to the second picture in this slide, the figure 2, it talks about how the different flows of data collection works. It starts with like whether you have enough data. If no, then what do you do? So you can go through this flowchart. Way it is represented, it will really help you to understand that why thinking data collection at the early stage of AI project will help to make the project successful. There are two more papers I would like to highlight. One is written by lead author Steven Yujung Wang. It's about data collection and quality challenges in deep learning, a data-centric AI perspective. The other one is synthetic data in AI, challenges, applications, and ethical implications. This is a very recent paper. Go through them. All these three papers have a lot of insight on how data being collected, what are the challenges, and what are the different kind of implications, including ethical implications. There are many more papers. You can go to archive to find about them, but I think all these three papers really stand out. So with that, we are coming to an end of this episode. Hope you liked it. Let me know your feedback or comments. Next, we are going to dive into data pre-processing. This is where our journey in learning AI and machine learning steps really starts. There are a lot of pre-processing activities required before the model can be trained. And in some estimation, it's up to 50 to 60% of overall effort where data scientist and AI engineer will be spending their time to clean up data, pre-process data, and make it ready for model consumption. We'll also start looking into coding in upcoming lessons after we go through theoretical aspect of pre-processing. So get ready. We're getting into deeper insight all about AI. Thank you so much. Looking forward to see you again in next episode.